This is non-calculator question number 15. College Board is asking us for the solution to a radical equation. I can solve this algebraically by squaring both sides, and I'm going to, but that's going to have potential issues. I prefer to substitute in answer choices. Let's substitute in x equals -1. That gives us the square root of -1 plus 2 equals minus -1. So root 1 equals +1, and that is true. So the correct answer will have -1 in it. And that also means there are solutions, so D is wrong. Let's try x equals 2. That gives us root 2 plus 2 equals -2. Root 4 equals -2, and that is not true. Square root of 4 is +2, and that is not equal to -2, so choice A is wrong. Even though -2 squared is 4, the square root of 4 is not -2 because the symbol square root means the positive square root only. Now let's try this algebraically. I have root x plus 2 equals -x, and I'm going to square both sides. So that's x plus 2 equals x squared. If I subtract x and I subtract 2 from both sides, I get 0 equals x squared minus x minus 2. If I factor, I get x minus 2, x plus 1, and that product is x squared plus x minus 2x is minus x minus 2, so that works. I have a product that equals 0. That means either the first factor is 0, and if I add 2 to both sides I get x equals 2, or the second factor is 0. And if I subtract 1 from both sides, that gives me x equals -1. The algebra suggests that choice A would be the correct answer. However, when you're solving radical equations or rational equations, you have to check for extraneous solutions. That's solutions that come out of the algebra but don't actually work in the original equation. Given that we have to do that check anyways, and this is multiple choice, I prefer to do what I did at the start. Just start with the choices, plug them in, because after the algebra I'll have to do that anyways. On the SAT, to save time, I'm going to skip the algebra completely. Congratulations to my students who are graduating today and moving on to college, and come back soon for my next video. With math, there's always more.